going to be a short demo showing a library that deals with Garmin's fit data for fitness activity, biking, running, heart rate, speed, elevation, that kind of stuff. So it's implemented in Glamor's Toolkit, which of course makes it extra fun and exciting. So this is just a little Lepitor page that I was working with to document the format. They have a little website for the format, and it talks about, let's take a look here. Let's go here and here. So it has an SDK, which we can take a look at. And when you download the SDK, it gives you a little CVS export tool. So rather than, unfortunately, the SDK only comes in not fun, static languages. We got C, C++, Java. I'm not interested in dealing with any of those, so we're just going to use this CSV export tool to turn the fit files into a CVS file and then deal with the data from there. So it's not a full implementation. One fun thing is that the dates, they decided to have their own epic. The DOS and Unix epics were not enough for them. So if you're looking to decode fit data, you have to know about that, which we do. So I've already installed the SDK and the Java jar CVS exporter. So I'm going to go to our fit protocol package. So we have two main kind of entry classes. So a fit data resource is a resource from the Resources Live library. So what it does is it takes a file, you specify your extensions, in this case fit is the only extension, and instead of dealing with raw files, we're going to turn them into resources which abstract away both the location and give you some domain specific behavior. So the files are in Dynabook data, which is, let's see where that actually goes to. It's part of the Dynabook project. Okay, so that'll be home Dynabook user data and fit data file. So we're going to create resources for all the fit data files. And right now there's only one, and there it is. So now we can deal with these as actual fit data and not as pouring files. So we can turn it into raw CSV. We can turn it into a little more interesting. We can turn it into a fit activity. And then the fit activity, this was for a biking activity. So we have cadence, which is like how fast you're pedaling. And we can, let's see here. We can chart that. There we go. It also uses the data frame project underneath from Polymath project. So we can have a data series on cadence, and we can look at some interesting stats. This stats view is actually a custom view of the fit protocol. That's an extension on the data series. So we got the average, median, max mode, etc., all your standard mathematical analyses. And let's see what else here. We have power. That's another metric you chart on the bike. It has something to do with the resistance combined with how fast you're pedaling in watts. So these are typically what you find with visualization software of fit data. These are this is the kind of the level of graphing. Obviously we could go much further with GT, but it's just a little demo. And it's an impartial wrapping of the protocol. As I said, it doesn't have speed. It just has cadence. In this case, it converts the resistance from Peloton to Peloton from Echelon because it was on an Echelon bike. And so that is not too generally interesting. But if you have an Echelon bike and a Peloton subscription, then that's very interesting. And just a quick word about the Peloton resistance. I'm just going to So this is actually a whole interesting, creepy world into itself. There's no real 100% way to convert Echelon to Peloton, but they have a kind of an underground network of people that are interested in how to do that. So what you actually do, and this would be if you had a bike besides an Echelon. This is a kind of a rough metric, but if you had any bike, you can go to. I didn't put the link here. Actually, I should add that to the doc. There's this kind of Echelon Reddit wiki that tells you how to, on your specific bike, you match up cadence to resistance, and you can figure out what your conversion is. Because actually, apparently, even Peloton to Peloton bike can vary by 10%. So right now it's hard coded, but as the need arises, we can make that configurable. So this is just a little example how in basically 3 classes with half a dozen methods, we're able to take a binary format and create some really nice visualizations. Now, the other thing I should mention is that instead of going through the data resource, you can go right through the activity and go all from files. It's just a little bit straighter route than going through the resources, which you usually don't care about the resource per se. All right, so that is the demo. If you want to play with this, it is on GitHub. It's Fit Protocol 4 G Toolkit is the repo. And I just put it up so there's not too many instructions, but there is a Metacello baseline to do the loading, and it should load cleanly on current GT. Thanks.